Alright guys, this is Unit 8, Lesson number 2, and we're going to continue to work more with the parabolas, which remember are the graphs of the quadratic function. So the graphs of the quadratic functions are more complex than linear and exponential because they include that turning point, which is either going to be the maximum or minimum, which we'll talk about today. And we'll just explore some more of these features and help you use your calculator a little more. So what we're going to do is first consider this first quadratic right here. So with the parabola in the form here, so basically you know your B and your C are zeros, your A is here, where A is the leading coefficient. We want you to fill in this table. And to give you a little help, what you need to realize is with this negative x, a lot of you guys would get this wrong. You think that when you put this in, you would do something like, let's say I put -3, and then you'd square it, and you'd say, oh, that's 9 because -3 times -3 is positive 9. But the squared is only going on the x, not the negative. So you're really only squaring this 3 and not the -2. So the way you have to think of this is really more like this. There's a -1 out in front of the x squared. So now you're going to insert that in there. So what we want you to do is fill this table out. So here's your input values. Input it into the function. Show a little calculations here. You don't have to do a lot, but show some calculations, and then do the output values here, and write them as a point like we have here. So write your x and y. So go ahead and hit pause and fill in this table for me now. Alright, let's see how you did. So with these you can see that you should have done something like here where you input the -3 in for the x. -3 squared is 9. And -1 times 9 is -9. Now you don't really have to show all this work. What I would like to see is at least you put this step in the middle, showing what you're doing with the input value, and then from here you can use your calculator and go straight to that step. So again, you wouldn't have to show it all. So then I'll just move these out of the way. And there we go. So hopefully you came up with those points, and you can see all the different features of our quadratic. We have our little patterns going on here that we talked about last lesson, the 9 and the 9, and then the forward 4, 1, 1. Okay. So go ahead and at this point, we want you to graph the parabola on the table of the table right here. So find the graph, and then you could also answer the range problem and figure out what the range was. So hit pause and do that now, please. Okay, hopefully your graph came out looking something like this. This looks a little different than what we did on last lesson, so we'll talk about that, but it's still that parabola. It still has what we've been talking about, the axis of symmetry, where I could cut it right down the middle, and this would be the axis of symmetry, and that's actually when x equals 0. It's right in the middle. And then we talked about the turning point. That's this guy right here. So it's actually right at the origin, so that would be 0, 0. And the graph is increasing right here. It's going up and up and up. Hits the turning point. Now it's decreasing right there. So there's some intervals you could talk about. And what is the range? Remember, the range is the y value. So really all you have to do is look at this here. And you can see that the maximum value is 0. And then it's going below that. And these arrows indicate it's going on for infinity. So it's going to just keep going. So basically you'd want to write your range something like this. So y is less than or equal to 0, or again you could write it like this where it goes from -50 to 0. So this graph's going to continue all the way down the y-axis. Alright, so there's a little basic graphing that we've worked with. Let's keep going on with this. Alright, on these, what we found out was last lesson, most all our parabolas were opening up kind of like this. And that's what we call concave up, or opens upward. And then this last one we just graphed looked more like this, and that's called concave down, or opens downward. And there is a way for us to determine if a quadratic function is going to open upward or open downward. So we're going to look for some patterns. So first what you're going to do is use your calculator. Now set your window, and these are your y max, y minimums, x max, x minimum. So set a correct window. You could put this function in your calculator, bring up the table, and then hit the graph, and you just sketch a rough graph it. It doesn't have to be exact, but look at your calculator and go ahead and try to graph these three functions right here. So hit pause and graph the three functions that you see right now. All right, how did you do? Did your graphs come up looking something like this? So hopefully you have something roughly like that because it doesn't have to be exact. Now, do you notice a pattern? So this one is opening upwards, this one's opening downwards, and this one's opening downwards. So what is it about this function that's different than these? And what is similar? Why are these two opening downward? Do you see or have a guess why? Well, what some of you might have noticed is look at this. This 3 here is a positive, and the leading coefficient here is negative, and the leading coefficient here is negative. And it might make sense that a negative opens downwards and the positive opens upwards. So we're going to explore this idea and see if it still works. So if you like that, you get to do it 6 more times. I know, exciting. So these ones will be easier. But what we want you to do is go ahead and sketch them all, not just these 3, but these ones also. So sketch all 6. So use your calculator, come up with a graph, and see if you could go ahead and do that now. So hit pause and graph all these functions for us. All right, how did we do? Now, was our observation right? Since these are all positive leading coefficients, were these all opening upwards? And if you graphed them right, they would come out looking something like that. So since these were all positive, they open upward. Also, something that we'll explore in other lessons is notice as this started smaller, look how wide this opened. And this one is a bigger number, and notice this is narrower. So things like that, how this opens up, is also, we're also going to look for that in later lessons. All right, so let's look at the next 3 here. How did you do? No, notice these have a leading coefficient of negatives. So if our observation's right, these should have come out opening downwards, and they did. Notice how this kind of controls how wide these are too. All right, so what we noticed is that if we have a parabola, the parabolas will open upwards, in other words, look like this, if what? If this leading coefficient is positive, and positive numbers are obviously greater than 0. So if your A coefficient, your leading coefficient, is greater than 0, your graph is going to open upwards. If it opens downwards, looks like this, we know the leading coefficient should be negative or less than 0. And I have a fun way to think about it. So if this is positive, we represent that with a plus. And when you're positive, you smile, right? You're a happy person. You're a positive person. So I call these happy parabolas because they're positive. That looks kind of evil for some reason. I don't know. There we go. Be nice. And then this guy over here, he's negative. And when you're a negative person, what do? You frown all the time. So I call, or you're sad. So this is a sad parabola. See, he's really sad. And this is a happy parabola. So we'll talk about those in class. But that's all you really have to get out of this lesson. So nice and short, easy one. And we'll see you in class.